Hello, welcome everyone. Thanks for joining us in our show. Let's talk about data. It's Monday, new week, new topic, and as usual, it's data related one. My name is Ibrahim Amara. I'm a database specialist solutions architect here at AWS. I'm based out of London and I'm one of your regular hosts. Today, we have an interesting show where we are going to discuss the topic about the Oracle Database at AWS offering, the new offering that we have announced recently that became GA just 2 months ago. And for that, I'm really pleased to be joined today with my colleague, Jobin Joseph. Jobin, would you like to introduce yourself to our viewers?
Sure. Thanks, Ibrahim. Hi, everyone. Thanks for joining us. My name is Jobin Joseph. I go by Joe. I'm a senior database specialist SA, like Ibrahim, but I'm based out of Toronto, Canada, part of the North American team. And I primarily focus on Oracle database related services and features and offerings, helping customers migrate their Oracle workloads to AWS. Very excited to be here to talk about the new partnership with OCI called Oracle Database at AWS.
Thanks, Joe. And for all of our viewers, we have Jeff, our AWS producer, and we have Tony. They are helping us with the chat. If you have any comments, if you have any questions, please keep them coming, and they will help you with that. Just to regarding the show today, we'll have this as two-part series. The first part will be today when we'll be covering some basic topics about the Oracle database at AWS, the architecture, and then next week, same time, we'll be covering the second part of it, some aspects about the in-depth connectivity and network aspects of the offering itself and the operational tasks related to it. So we have Iri Edit. Hi everyone, excited to watch. Thank you so much, Iri. And watching from LA. Thank you. So, Joe, let me start by talking about that offering that we have. I know that we have announced this offering last year, but it became GA end of June, something like that, or early June. Excuse me. So, what what's so peculiar about this offering? What's so different about it? And when we are talking about the Oracle database at AWS, what does it mean?
Yeah,
And how it's different from the other services that were already being provided for hosting the Oracle workloads.
right. So let's talk about a little bit of history about customers migrating Oracle workloads to the cloud, right? So AWS has been a trusted leader helping customers migrate their Oracle workloads to the cloud. We had self-managed databases on EC2 ever since EC2 was available since 2008. And we introduced RDS for Oracle, a fully managed database service to run Oracle databases in the cloud in 2011, which offers customers with a service without having to worry about any administration overhead or operational overhead. And later in 2021, I believe we introduced RDS Custom for Oracle, again part of the RDS family, but offers further flexibility and elevated access for workload that requires such level of access requirements. And we always had EC2 I talked about, but the problems with this existing offering was some of the customers were running their Oracle database workload in Exadata and real application clusters. And migrating those workloads to AWS using one of the existing services was sometimes becoming a challenge for a customer because there was no Exadata platform available in AWS, and there was no supported way of running real application cluster in AWS as well. Some of these customers still migrated Exadata and RAG workloads to AWS by going through some kind of configuration changes and workload optimization to remove that hard dependency on Exadata, for example, or real application cluster for high availability and leveraging some of AWS native capabilities like multi-AC. But there was still some workload that had kind of hard dependency on Exadata features for performance, the magic features offered by Exadata for meeting the workload throughput and performance requirement, and also for real application cluster for zero downtime patching kind of features. So we heard from our customers about these challenges, and to meet those requirements, we partnered with OCI to come up with this offering called Oracle Database at AWS, which is based out of Exadata, and we can talk about a lot about that in next half an hour plus. And this is also support real application cluster as a feature integrated, so customers running their workload on Exadata and RAC can experience a true lift and shift migration experience without having to modify any code, any configuration changes. They can migrate them easily into AWS now.
Yeah, and I remember that we had a show um, earlier last year or the year before when we were discussing the alternatives for migrating RAC workloads to AWS. Around that time, we didn't have this offering available, and yeah, and also because uh, I've been also working with customers where some challenges when it comes to, especially for those workloads who are heavily dependent on Exadata features, and there were no equivalent, something equivalent on AWS for that. So I believe, yeah, this offering is filling a gap here for those particular workloads, that especially for big enterprise customers. We have our viewers. Viewer, hello, watching from North Carolina. Hello, how are you doing? And our regular viewer, Data Guy. Hey, and track is great for rolling patching. Big fan of it.
Me
Okay.
too. I'm a big fan too.
That's perfect. Okay, and schizophrenic web developer. Hello, hello, Vector. Okay, perfect. Okay, so back again to the offering. You mentioned that as part of this offering, our customers will be able to run in their workloads on Exadata machines.
That's correct.
So does this mean that those Exadata machines will exist inside the AWS data centers?
That is true. Let me explain with a kind of a brief introduction to the service itself. So, if I
Okay.
have to explain what Oracle Database at AWS in a single sentence, I would say this: Oracle Database at AWS is a marketplace offering to offer to OCI database services to AWS customers with infrastructure deployed inside AWS data centers, so that customers can expect low latency connectivity from their database running on that offering to the rest of AWS ecosystem. For example, applications hosted on EC2 instance, or any analytics integration or generative AI applications, they can expect low latency connectivity, right? So to answer your question, yes, this is based on Exadata infrastructure inside AWS data center, and we can probably see some of the advanced details of it when we look at the architecture. But these Exadata infrastructure or the hardware is placed inside AWS data center, inside child side, we call it child side of OCI, because they kind of extension to OCI's parent region inside AWS data center. And that's where the Exadata infrastructure is placed, and it is managed and deployed by OCI. And then customers can create infrastructure, host their VM clusters, and migrate the databases into that, so that they get the same experience as running their workload on Exadata on premises, same Exadata hardware, same Exadata features, same rack features. So there is no difference in the way how the platform meets the workload requirements in terms of running that on the Exadata hardware.
So when we are talking about the features, like Exadata features like the query floating, smart scans, the hybrid columnar compressions, all these features are available as part of the solution.
That is correct. So the supported Exadata model part of Oracle Database at AWS is X11M. So whatever features you can expect from running X11M in OCI or on premises, you will get the same capabilities, the same hardware, all the capabilities of Exadata, all secret source features of Exadata, including cell offloading, smart scan, storage indexes. All those features are going to be available part of Oracle Database at AWS offering as well. And I talked about two OCI database services being offered part of ODB at AWS, sorry, Oracle Database at AWS. The two services are one Exadata database on dedicated infrastructure, very similar to Exadata Cloud Service in OCI. The difference is that Exadata database on dedicated infrastructure, part of this offering will be based on the hardware deployed inside AWS data center. And if you compare with the native Exadata Cloud Service in OCI, that's based on the hardware sitting in OCI itself. So that's a primary difference between ExaDB part of the offering versus the native Exadata Cloud Service in OCI. The second database service is Autonomous Database, another OCI database service, very popular because of its machine learning integrated automated features. So again, the variant of Autonomous Database offered part of Oracle Database at AWS is called Autonomous Database on Dedicated Infrastructure. And the keyword dedicated infrastructure here means is that you as a customer, when you run your databases on this offering, that will be hosted on dedicated infrastructure for you, meaning you have a dedicated set of DB servers and storage servers that is fulfilling your workload requirements. So the compute power, memory, and the storage is not shared with any other customer. It's not a shared tenancy. The reason I'm highlighting this difference is because in OCI, you have autonomous database available in two deployment models. There is autonomous database dedicated, similar to what we have part of this offering, and there is also autonomous database shared or serverless, which is a shared tenancy model where your data may be shared with other customers running on the same Exadata infrastructure, being a shared platform as a shared tenancy offer. So that's the difference between the autonomous database available in OCI in two different variations, ADBD and ADBS, while in case of Oracle database at AWS, the option available is autonomous database on dedicated infrastructure only.
Okay, so from operational perspective or managing the resources, how the both services are different, how the autonomous database on dedicated infrastructure is different from Exadata dedicated infrastructure or
So
HDB.
that Yes, so the difference between Exadata database service and autonomous database in OCI, if you look at the responsibility model in terms of what customer is responsible for versus what the cloud provider is responsible for, that responsibility model applies pretty much same here as well, but there is an additional uh, party playing the role, which is AWS, and we will talk about it. But comparing the responsibility model between Exadata database service and autonomous database is that with Exadata database, though you don't have access to the physical DB servers and storage server, you get access to the VM cluster level. When you create the VM cluster, you can do SSH to the underlying VM. You can connect to the database as, for example, sysdba. You can do any customization that you want to do, as long as that is kind of certified by Exadatabase as a service. And you can also install additional, for example, software modules, monitoring agents, whatever customization you would like to do. Those features and customization requirements are supported by ExaDB. Basically, ExaDB is, think of like, instead of you running Exadata database on premises, where you're responsible for arranging the space, power, cooling, everything, you're running that in the cloud. With OCI is taking care of most of the aspects, including administration, deployment, scalability side, things like that. And you're just provisioning VM clusters and databases on top of that. You're responsible for VM cluster management, including, for example, applying patches to the operating system, applying grid infrastructure patches and database. But that management experience of running that in the cloud will be different from how you do that operations in on-premises world, because there are a lot of cloud tooling available to make that process extremely easy for you. And if
Yeah,
you
because that will take me. I'm sorry for to interrupt you, Joe, but that will take me to this question from Data Guy 13, which is asking about this exact same topic. Do you need to patch all of the Exadata, or is it done for you? And they are referring to, their painful experience from this perspective, or their perspective, while when they were doing that on premise. So
correct.
how it is different when it comes to patching?
Yeah, this question popped up at the right time because we were discussing the exact same topic.
Exactly.
Right. So there are multiple layers on the Exadata. So you have the physical DB servers and the storage servers. And the good news is that management of those physical DB servers and storage servers, including patching, is taken care by OCI. So you don't have to worry about quarterly patching of DB servers and upgrading your storage system software on Exadata storage servers. That's all taken care by OCI. What you do is you create VM clusters on top of that, and you have physical access to the guest VMs. Management of that is your responsibility as a customer. But again, like I said, you don't have to go through the painful experience of patching these DB servers and storage and applying patches to the grid infrastructure layer or DB level using manual command line tools. Instead, there are OCI automation tools available, which allows you to easily get it done using one or two commands. You can patch the entire VM cluster and grid infrastructure and database layer. Yeah, so it's kind of a splitting the responsibility between you as a customer and OCI. Compared to Exadata, running Exadata on premises, it's much more easier, and your responsibilities are shorter as compared to running this in on premises world.
Perfect. Thanks, Joe. Okay, so right now, do we have poll offerings available for customers? So for both the ADB or the autonomous database and Exadata on dedicated infrastructure.
So, if we talk about the journey of Oracle Database so far, like you initially mentioned, we pre-announced this in last September, 2024 September, and we got tremendous response from our Oracle community and customers. Looks like we were hoping that customers will see that as a surprise, but looks like a lot of customers were expecting and waiting for this to happen.
Yeah,
Um, and we did the private launch of the offering at reInvent last year, December timeline, and we got a lot of customers started doing the POC and getting into the initial phase of testing the performance, connectivity, and things like that. And we started with only one service out of the two services part of the offering. We started only with XRDP initially, and we started with only one region as well. US East one was the only region when service was initially available, and later we added the second service also into the offering, and we made the GA of the service, like you said, a couple of months back, July 1st week to be precise. And right now, the service is GA in two regions, US East one and US West two. And both regions support kind of a multi-AC deployment model where you can deploy an architecture that supports your high availability requirements and cross-region DR requirements. And we support both ADB and XIDB across these two regions. And at GA, we also pre-announced launch of this offering to 20 additional regions by end of 2025 and 2026 timelines. The launches are split into different quarters. So excited about the progress made so far, and we hope that customers will feel the same and start migrating their rack workloads and Exadata workloads to Oracle Database at AWS.
perfect. So, Joe, when I'm discussing this offering with my customers, and we were talking about the benefits that we'll be getting from um, an offering like this. So, apart from the fact that some of the workloads really needs to be on Exadata running or use on rack, stuff like that. So there are some other benefits that the customers will be benefiting from, like the integration, the native integration with the AWS services. the unified experience of managing the resources. Um, can you give us more details about that?
Yeah. So when we talk about the benefits of Oracle Database at AWS, or what should customer expect when they migrate their workload to Oracle Database at AWS, the primary use case, like you said, is based on those workload that have dependency on Exadata and rack, and we already talked about it. Customer looking for easy migration of those into cloud, for example, to meet quick data center exit timeline, and they want an interim platform to immediately migrate out of Exadata on premises and host them in the cloud while thinking about the long-term migration strategy, going through modernization to Aurora or whatever. So that's being the primary use case for consuming Oracle database at AWS. But there are other benefits as well, like you said. Oracle Database at AWS, though it is a marketplace offering, the experience we are providing to customer is very similar to any native service. So there are a lot of native integration with AWS, other AWS services. For example, one of the common challenges we hear from customer is data silos. Customers will have their data running data stored in many places. On premises world, probably transactional data is hosted in Oracle database on Exadata, which is on premises. Some of the data is already in AWS. So customers are not able to leverage full value of this data and use it for example, analytics purpose or for building generative AI applications because of this data
Mhm.
silos. The benefit of Oracle database at AWS is that it comes with zero ETL integration capability from the database running on Oracle database at AWS to AWS analytics services. As of today, we support Amazon Redshift as the target for
Mhm.
zero ETL integration. What that means is that without having to build a manual complex data pipeline, with few clicks in the AWS console, customer can build an automated zero ETL capability where transactional data stored in Oracle database at AWS will automatically replicate into Amazon Redshift. And once the data arrives at Redshift, it opens up wide capabilities. For example, they can use Redshift ML for analytics and services. And Oracle database at AWS supports Oracle database 23 AI version that
Mhm.
comes with some of the unique vector search and vector store capabilities, and customers can combine those features, also leveraging the LLMs models available in Amazon Bedrock to build generative AI applications. So that's one of the integrations, but the integration doesn't end with just with zero ETL and Redshift. We also have integration with Amazon S3. S3 is the default backup destination for automated backup, for which is kind of fully managed backup experience for database running in Oracle database at AWS. And we also support integration with other AWS native services, including CloudWatch, CloudTrail, EventBridge, connectivity using Transit Gateway, VPC Lattice. So again, though it is not a AWS native service, but we're trying to get an experience for a customer which will look like an AWS native service.
And yeah, for all of our viewers, we next show next week will be focusing more on these integrations, and it will show you how the offering is integrating with other services. I believe we have like maybe we'll be having a demo for zero ATL or something like that, or S3 integration. We can have something like that. And also when it comes to the having a unified experience for managing the service, I believe this will be also part of the demo that we'll be showing our viewers today on how they can provision the Oracle database at AWS and how they can manage it. And from there, they can see for themselves that it's more or less like how they are managing other AWS services from the within the same AWS console, and what can be managed from the AWS console, what can be managed through API calls, what can be managed from the OCI console itself. So I believe that would be part of the demo that we'll be having. So for all of our viewers, stay with us. We'll be having a demo in a few minutes where we are going to show all these capabilities.
Yeah, one thing I want to highlight here, yeah, it's going to be a simplified, unified management and operational experience for customers.
Mhm.
Combination of AWS and OCI tools, existing skill set. Many customers already have marketplace subscriptions. This is going to be another marketplace offering that customers can leverage. But what I want to highlight is that while we were working with OCI, we wanted to make sure that customers get their favorite things in both OCI side and AWS side. So we wanted to make sure that whatever spend customer make on this offering, that is counted towards their commitment on AWS side and OCI side. So what that means is that customer subscribe this service, whatever spend they do, that will be counted towards AWS commitment and also towards Oracle support rewards on OCI side, that they benefit from both side, both multi-cloud of providers.
Yeah, I think that's some great news for the customers. And so when it comes to um, support, because we have some, um, there might be some overlapping here on. Uh, so to avoid any confusion for customers who are provisioning this service, so what they should do whenever they are encountering or facing an issue with the ODB at AWS service.
Right. So ODB at AWS kind of provides a joint support model for our customers to resolve issues quickly for our customers. So what we expect customer, if customer knows that the issue they're dealing with is purely an AWS side of issue, for example, zero ETL capability is not working and
Mm,
it's a purely an AWS side of issue, they can straight away raise a case with AWS. But for any other technical issues related to Oracle database at AWS, they can start with raising a service request with Oracle or OCI. And if there is any need to engage AWS support team for investigation or resolving that issue, that will happen behind the scene without
mhm.
a customer have to raise another ticket or contact AWS support. So it's kind of a collaborative support model, and the objective is to reduce the overhead on the customer to and resolve technical issues as fast as possible for our customers.
Okay, that's perfect. And I believe that will lead us also to ask about how it looks like or the customer experience in order to subscribe to a service like that.
Yes.
You mentioned that it's a marketplace offering, uh, but I think there are some other um, different aspects when we are dealing with this offering as well, in how the infrastructure is being provisioned and how the service as a whole is being provisioned.
Yes. So if you ask me how the customer journey will look like from the time of expressing their interest to start onboarded to
Yeah.
ODP data AWS until they provision in the resources. So customers who are interested in this offering will can contact their OCI sales team representative and get into the discussion of having a private offer. That would depend on how much of resources they need, what is the period of commitment, and based on that, OCI team will share a private offer in customer's account. Obviously, customer need to share their account ID with OCI team, where they can extend that marketplace offer to that specific account. And once that is done by OCI team, customer will be able to review that private offer in AWS marketplace in that account where the offer has been extended to, and they can review the terms and conditions, the dollar numbers, and once they are happy with that, they can accept that offer. And during that private offer acceptance process, they will also link that AWS account to an OCI tenancy. Now,
Mhm.
I'll explain a little more details about that when we discuss the architecture. But just for the context of this discussion, this is OCI services, though it is provided through marketplace in AWS and it is deployed inside AWS data center. It is still an OCI service, so there are control plane resources in OCI side. To hold those control plane resources, we will be linking the AWS account where we are accepting the private offer with an OCI tenancy. That can be a brand new tenancy if customer is not an existing OCI customer, for example, or if they
Mhm.
are existing OCI customer, they can reuse one of the existing OCI tenancy, and the resources will be grouped into a subcompartment for multi-cloud. So it won't be into an existing command, but it will be completely, totally different grouping together. And during that private process, we will complete the linking process between account, AWS account, and OCI tenancy. And that kind of gets them ready to kick off the provisioning process, and they will basically create some resources on AWS side, the infrastructure, the networking component, and the VM cluster. These resources are created from the AWS console or APIs. And once that is done, they will switch to the OCI side to create the database resources and manage them from OCI. They can also create the DB resources by doing SSH into the Exadata VM clusters and then running DBA CLI kind of OCI provided tooling to, if you like, to stick to a command line interface or API calls instead of using OCI console. That's a possibility as well. CloudFormation is supported today, and we are hoping to support Terraform pretty soon as well.
Okay, I see. And when we are talking about also the resources being provisioned and the offer itself or the marketplace offering and all that stuff, I believe for big enterprise customers will be having like multiple accounts. There will be some flexibility in sharing these resources across different accounts, and I think next week we'll be discussing in more details how these resources can be shared across different accounts within the same organization. But this is a flexibility that should be there, right?
Correct. I think this is some of the basic requirements most of the customers have. They should be able to, because Exadata infrastructure is a heavy resource. It comes with
Yeah.
one thing I did not mention is that the dedicated infrastructure, the minimum configuration required is equivalent to a quarter rack of Exadata, which is 2 DB servers and storage servers. And for some customers, this is a pretty big or kind of high resource available hardware. They may not be able to consume all the resources within one account or within one
Yeah.
business unit. So the sharing capability is a key requirement we hear from our customer, and there are some features supported around that, and we can dive deep into probably in the follow-up discussion.
Perfect. And I think in order to make things clear, maybe we can show our viewers the architecture of the
Oh,
solution
yeah.
itself.
Yeah, I think it's important to understand the architecture before we see the demo. So let me bring up my slide just to show the architecture. Okay, so don't be worried about the slide being blank. I'm going to bring more components to it with animation. I'm starting with the blank side so that it will be easy to understand. So just to explain the architecture, I'm taking example of a region where the offering is currently available. So I'll go with US East region. So in that geolocation, AWS has a region, which we call it as AWS region US East 1. And OC has also a region in the same geo, and they call it US Ashburn 1. And what we have done is inside the AWS region in a specific availability zone, there are a specific area or data center where we host the Exadata infrastructure, and that's called OCI child site. That specific data center where Exadata infrastructure is hosted inside the availability zone is called OCI child site. And think of OCI child site as a extension to the OCI parent region inside AWS data center. So that's where the Exadata hardware is kind of deployed, and it is fully managed by OCI team. There's complete segregation of roles and responsibility between AWS and OCI in managing and deploying this hardware. And this is on top of this Exadata infrastructure, customers create VM clusters for their ExaDB databases and autonomous databases. So it could be either Exadata VM cluster, autonomous VM cluster, depending on whether they want to create ExaDB databases or autonomous databases. And both of these clusters can coexist on the same Exadata infrastructure with a limit of maximum 8 VM cluster per Exadata infrastructure. Now, Once the VM cluster is created, you can create the databases either using the CLIs or by switching to OCI console. You will create the databases on top of these VM clusters. Now, on the AWS side, to host the network resources of Oracle Database at AWS, we are introducing a new network construct called ODB network. Now, the if because it's a new network construct, if you want to compare with an existing AWS resource, just to understand it better, you can compare it with a VPC, but there is a lot of difference between a VPC and ODB network. ODB network can host only Oracle database related resources, while in VPC you can have any kind of AWS resources. So there are a lot of similarities between ODB network and VPC, but at the same time, there are a lot of differences as well. So ODB network is a mechanism that we use in AWS side to host all the networking requirements of Exadata. For example, you know that Exadata requires the client network, the backup network. It requires scan IPs and scan host names. So all that comes part of the ODB network. And when you create ODB network, you will mention what is the CIDR range for backup subnet and what is the CIDR range for client subnet. Very similar to when you create a VPC, you mention CIDR ranges. So here also ODB network, when you create, you mention the CIDR ranges. And in the backend, that ODB network is actually mapping to an OCI VCN, virtual cloud network, on the OCI control plane. So the CIDR ranges you mentioned for the backup subnet and client subnet, they effectively becomes the CIDR ranges for the OCI VCN subnets also. Now, as I said, ODB network is a mechanism to hold the network components of Exadata. It is also the mechanism to expose that Exadata's network components to AWS ecosystem. For example, if you have a VPC where your applications are running, for example, EC2 instance in applications hosted on EC2 instances, they can establish connectivity to the database tier just by peering that VPC into ODB network. The terminology is called ODB peering because you're peering an ODB network within a VPC. But conceptually, which is similar to a VPC peering, only difference is that with the VPC peering, you're peering two VPCs, but with ODB network, you're peering a VPC to ODB network. And with that peering, applications sitting in that VPC, any subnet can establish connectivity to the database by routing the connection to the client subnet. So that's the architecture at very high level. So like I showed you in the previous diagram, the primary mechanism to connect to the ODB network or to the database running on Oracle Database at AWS is by peering the VPC where your applications are running to the ODB network using the concept of ODB peering. This provides the low latency connectivity options from your VPC to the ODB network. But today there is a limitation of only one VPC can be peered to the ODB network. So in cases where you have connectivity requirements or you need to extend the connectivity to outside that VPC, that's where you can leverage Transit Gateway. So with Transit Gateway, you have an option to extend your connectivity from multiple network segments. It could be other VPCs running in your account, other VPCs in other regions, or other accounts, or even it could be on-premises network segment. So connectivity from all those network segments can be made through ODB network by using Transit Gateway. So you can see there is a Transit Gateway attachment made to the Transit VPC that is paired with the ODB network. So ODB network doesn't support a direct attachment to Transit Gateway. That's why we still need a VPC that will act as a Transit VPC, which will sit between the Transit Gateway and the ODB network. And that Transit VPC will be directly paired with the ODB network through ODB pairing that we discussed in the previous slide. And pretty much the same architecture works where if your application VPC is in different account, or if it is a different region, just the transit gateway configuration will be slightly different. And even from on-premises network connectivities, for example, if you have migrated just the database into Oracle Database at AWS, and you still have some applications that needs to connect to the database, you can establish connectivity through direct connect or VPN, and then use transit gateway to route the traffic through the transit VPC to the ODB network.
And in all these cases, the traffic is private traffic. They are not going through the public internet.
That is correct. Yeah.
Okay, so from the application perspective, it's transparent to them where this Oracle database is hosted. Is for them, it's just scan IP being translated to a host, and then it will lead them or will connect them to the database itself, and that's it.
Correct. So during the configuration, there is an additional step we do for the DNS resolution. So there is a DNS listener running on the ODP network that is automatically created during the provisioning process. So we just need to do the delegation of the DNS resolution to the DNS listener for any Exadata related DNS names, for example, scan name, and then application components can resolve the scan IPs and then connect to the database. So connectivity wouldn't be much different from how the connectivity would be in the on-premises world. For example, you may have standby database, primary database, and then there'll be multiple addresses in the DNS connect string using multiple scan names. So, and role-based services, the basic connectivity architecture wouldn't be any difference in ODB connectivity either.
Perfect. And then the same high availability features whenever one RAG node is down, then again, the scan will be forwarding them to the available node. So all of these features are available. And I believe also we'll be talking maybe next time about the different maximum availability architectures and how to implement each one of them using this offering, and how to leverage the different AZs for AWS AZs to do that. Okay, perfect. So let's translate this into actual steps inside the console itself, and let's see how you are going to create something like that inside the AWS console.
All right, let's do that. So let's see what we discussed in action. So like I said, Oracle Database at AWS gives you a native service experience. So if you search with Oracle Database, you can see that as a native service kind of experience. So it looks like a native service in AWS console. There are CLI and namespace in API calls called ODB to represent this as a kind of a native service. So if you go into the home page, this is the dashboard you're expected to see.
So Vector saying, yeah, let's see, yeah, agree, let's see that. He was also saying that the diagram's always the more interesting. Agree with you. Okay.
Yeah. So the dashboard that you see here, it's currently enabled. You can see that it is not grayed out. But if you're a new customer trying to access Oracle Database at AWS as a service in your console, you will see the dashboard is disabled initially. That's because if you haven't accepted the private offer, the dashboard will be grayed out. That's how the experience is built. And then it will take you to the marketplace where you can review the private offer. If you already have the OCI discussion happen and they have extended the private offer with you, you'll be able to see that and then review and accept the private offer. Or if you haven't done that, it will give you an option to request for a private offer, and then you can initiate the contact and conversation with OCI to get that done. So in my case, on this account, you see the console or dashboard enabled because I have already gone through the marketplace acceptance process, and the prerequisite is completed. I have already completed the linking process with OCI tenancy. So I'm just going to start with the step of creating the resources. The prerequisites have been met already, which is basically accepting the private offer and linking the AWS account with an OCI tenancy.
Perfect.
All right, so click on the dashboard. So on the left panel, you can see various resources available on the AWS control plane. So, like I earlier explained, the ODB network is the key networking resource that we just discussed. We will see how to create that. This is Exadata infrastructure. You are creating your desired configuration with how many DB servers and storage servers you need. And then you're creating VM clusters on top of that. It could be Exadata VM clusters or autonomous VM clusters. And the peering connection is the mechanism to peer your VPC to the ODB network for required application connectivity. So to get started, you can either start with ODB network or Exadata infrastructure. Because Exadata infrastructure doesn't have any networking component associated, it's just the physical resources getting provisioned for you inside a specific availability zone. So you don't need ODB network as a prerequisite, but we normally recommend customers to start with ODB network to kind of follow a specific flow of deployment process. So go to ODB network. I'll show you how to start a new ODB network creation. You put a name to it and choose availability zone. So ODB network is a AC specific resource. That's one of another is difference between an ODB network as a VPC, where VPC is more like a region resource. ODB network is only available in an AC. It's an AC specific resource. You can choose whichever availability zone where you want to deploy your ODB network. So basically your Exadata infrastructure, ODB network, VM cluster, all the resources will be mapped to a specific availability zone. And the list down menu here will show you which are the availability zone where Oracle Database at AWS is currently available in that region. So in US East 1, it is available in two regions, in AZ4 and AZ6, and you will see the logical zone IDs here. So I'll choose one of the.
So Joe, is part of the offering itself when you are providing the details, you are going to provide the details about the availability zones that you're going to run your databases in?
Correct. Yeah, the region
Okay.
and the specific availability zone where you're going to host your resources. Yes, that is correct.
So,
It's part of
so
the
that
offerings.
so the ODB network has to map to the actual physical location of your Exadata machines.
That is correct. Yes.
Okay.
So the
And
assumption is that I'm going to create all my resources in a specific availabilities on USDs to 1C. The infrastructure, I was probably told by Oracle that that's where you need to create your infrastructure. That's where hardware is available, or that's where customer wants to create the hardware because most of the applications are hosted in that availability zone. So that's an agreement that happens during that of discussion as well.
okay.
So you can mention the CIDR range for your client subnet and backup CIDR range also. So you need to ensure that this CIDR range doesn't conflict or overlap with any of the CIDR range where you will be establishing connectivity from to this database or ODB network, right? So you may have some VPCs that you want to connect to, or your on-premises network. So the CIDR range can be mentioned. There are some service integrations capabilities available. We have talked about Amazon S30 ETL. You can enable those configurations here just by clicking these checkboxes, and that's pretty much it. And you can optionally put a domain name prefix for your domain name. So all the domain name will be derived from this value. So if you like a kind of a preferred domain name, you want to kind of reproduce your existing domain name, you can put that prefix here, and that will be used as a prefix for scan and other host names. And then you create ODB network here. And I'm not creating one because I already have one. And then we proceed to create an infrastructure resource.
So the Exadata, as you mentioned, the ODB network is not dependent on the Exadata infrastructure and vice versa. They are not
Correct.
dependent on each other. They will come into play when we are talking about the VM cluster, provisioning the VM clusters themselves. So in this case, the customers, if they have like Exadata infrastructure, they can create multiple ODB networks, and then they can attach each one of them to a different VM cluster on the same Exadata infrastructure.
Correct. So if you look at the dependencies, and it's like Exadata infrastructure, one resource. On top of that, you can create up to 8 VM clusters. These 8 VM clusters can go into one ODB network if that's a
Mhm.
requirement, that meets the simplest configuration requirement for some customers. Customer may choose to do that. Or if suppose these VM clusters are for catering requirements of different line of business or different
Yeah,
applications, prod, non-prod, in which case these VM clusters may go into their own ODB network for complete isolation. So
and
though
that
they are though they are sharing the same physical DB servers and storage servers, they have one isolation at the VM cluster. Plus, they have
yeah.
network level isolation. Though they don't talk to each other. These VM clusters, though they are physically running on the same infrastructure, they can't talk to each other if they are deployed into a different ODB network unless you intentionally make that configuration to make that communication possible.
And in this case, also they can benefit from the having multiple ODB networks so that they can pair different VPCs to each. Yeah, so one-to-one pairing that we talked about.
Correct.
So yeah, each VM cluster can maybe serve different application. I know that we have less than 8 minutes, but up for our viewers, don't worry. We still have next week. We'll continue with the show, so we can continue with the demo, but let's continue for now. And we have a hot stop at top of the hour, but we will continue next week if we are not able to finish today.
Right. Thanks for the heads up. So let's move into the creation of next resource, which is Exadata infrastructure. It's very straightforward. You don't need to give a lot of details. You just need to put a name to your infrastructure and choose the availability zone where you want to host this infrastructure. And then this is where you will choose the available model. So X11M is the latest model available. I would expect customer to go with X11 because that comes with more power, being a later generation of Exadata hardware. And you can choose your desired configuration with DB server, number of DB servers and storage servers. It shows what is the resource available in each of the DB servers and storage servers. So basically 760 eCPUs and 80 terabyte of storage per storage servers. The minimum configuration is 2 DB servers and 3 storage servers, but you can choose your desired configuration to meet your workload. You can probably have a compute intensive workload where you need more DB servers and small number of storage servers, or you can have a data warehouse kind of thing where storage requirements might be really high and compute power may be required is very less. So you can have any combination of number of DB servers and storage servers within the limit of minimum requirement of 2 DB servers and storage servers. So you go with that, and then choose a maintenance window preference, Oracle managed schedule, or you can put your own schedule if you like that. This is for Oracle applying patches on doing maintenance activity to the physical DB servers and storage servers. Like I mentioned earlier, this is the responsibility of OCI. It's not something you do as a customer. So you're just only control you have on this is that you have a preferred maintenance window for Oracle to do it. That's what you can mention here. And you can also put notification email ID, and that's pretty much it. I have to choose some, and you can review the configuration and then submit the request for creating Exadata infrastructure. I think we have time for explaining one more resource creation, which is
Mhm.
VM cluster,
Sure.
which is the next level of resource. So for creating Exadata VM clusters or autonomous VM clusters, you must have a valid Exadata infrastructure created already, and you also should have an ODB network to host all the networking components of VM cluster. The VM cluster is an abstraction layer which consists of the rack, the grid infrastructure, the ASM, and the database software. So everything is part of the VM cluster configuration. So it needs a lot of networking resources. It need a domain name. It need a scan name, IP addresses. So everything comes from the ODB network. Remember, you mentioned the CIDR range for client and backup
Yeah.
subnet. So when you create a VM cluster, it is going to consume IPs from that. So you need to plan your ODB network configuration, like what CIDR range you need, /27 or /24, is dependent on how many VM cluster are you going to create and how many VMs are going to be part of the VM cluster. It's going to be 2-node rack cluster, it's going to be 8-node rack cluster. That would decide the CIDR range requirement for ODB network, and it is all well documented nicely in AWS and OC documentation.
Nice.
Okay, so VM cluster, again, you put a name, choose dummy names, and this is where you choose where you're going with bring your own license or license included option. Both options are available for our customers. So I'll choose bring your own license for example. You choose your Exadata infrastructure where you created the infrastructure with the desired number of DB servers and storage servers, and choose the grid infrastructure version. 23 AI and 19C are available. So if you go with grid infrastructure 23 AI, it has backward compatibility to 19C database. So always recommend to choose the latest version of grid infrastructure. You can also choose Exadata image version. Also recommended to go with the later version unless you want to exactly match your on-premises network Exadata image for any reasons. And this is where you can choose how many VMs to be part of your VM cluster. You can
Those are the rack nodes that will be
exactly.
okay.
Yeah, so you can, the maximum number of rack nodes you can have on the VM cluster is the number of DB servers in your Exadata infrastructure. Here I'm only given two options. Either I can go with the 1-node rack cluster or 2-node rack cluster, because maximum number of compute nodes in my Exadata infrastructure is 2. But if you, for example, you have 8 compute servers in the Exadata infrastructure, you can choose to have VM cluster with any combination of number of VMs. You can have 1 up to 8. So you may have multiple VM cluster with each of them having, some of them having 2 nodes, some of them having 3 nodes, depending on how the workload requirements are. And you can also configure the resource availability per VM, like how many OCPUs, how much of memory you need, how much of local storage you need, and how much of Exadata storage you need. And you can also choose how the storage allocation ratio is, that how much of that should be available for local backup and sparse disk group for fast cloning. All those configurations can be mentioned. You choose the ODB network where you're deploying the VM cluster to for the networking resources. You can put a host name prefix. You can choose the scan port name, and most importantly, you can also use an SSH key pair details, so that once the VM cluster is provisioned, using the private key, you can SSH into the Exadata VMs. Unfortunately, I won't be able to move forward. Okay, I think it accepted dummy value, so
Okay.
that we are good. Okay, so that you can configure some diagnostic collection options here and just review the configuration and create VM cluster. This process
Perfect.
is going to take approximately 5 to 6 hours because it deploys heavy components on the rack cluster.
Perfect. I think you're on time right now, so we only have 1 minute left. So thank you so much, Joe, for your time today, and for all of our viewers. Next week, same time, we'll be continuing the discussion about the ODB at AWS. We will see the created Exadata VM cluster, how to provision the database, the different topics. Also, we talked about the integration with the other AWS services, the different architecture patterns, and the connectivity as well. So
HADR also, yeah.
exactly, yeah. So wait for us next week. Please tune in, same time, and we'll be waiting for you. Thank you so much. Thanks again, Joe, and thanks for all of our viewers, and see you next week. Thank you.
Thanks, everyone.